Hello students, myself Dr. Anupreeta Mishra. You are watching Anupreeta Mishra's Electrical Engineering channel for clearing your electrical doubts, electrical concepts, everything. I have started Synchronous machine from the last video, and today I am going to start Synchronous generator, that is known as the alternator. And in this particular content, I am sharing you the brief about synchronous generator or alternator, a basic thing which should be known to you prior to starting each and every concept related to it, and before we are going into the depth of the concepts. Certainly in future you will be finding it very interesting one. This particular machine is too much interesting with respect to any other electromechanical energy conversion device. So let's start the synchronous generator. It is actually, as I said, transforming mechanical energy into electrical energy or mechanical power into electrical power. And electrical power can be in three phase or single phase. So certainly the two generators, synchronous generators, one is related to three phase power production, and second one is having single phase power production. We would be having the difference in their construction. This is well known fact. All the generating stations have a three-phase synchronous generator or alternator installed at their place, because in the world no single power system, electrical power system, can be existing without synchronous generator or alternator. This is the main resource for the electrical power generation at the generating stations. Either it is a hydel power station, or that is hydropower station, or thermal power station, or nuclear power station. There must be the synchronous generator or alternator existing over there. Actually, these alternators are of the capacity of hundreds of megavolt ampere, and for producing that much large amount of the electrical power, its armature winding which is being given over the or placed over the stator, that three-phase armature winding is having the rating of 6.6 kilovolt to 33 kilovolt. Actually, that much megavolt ampere has to be generated only with the presence of this high rating armature winding. This is there. So this is all about the brief about the synchronous generator or alternator. Now I am giving you the simplest working of synchronous generator, which makes you understand that how it works actually, what is happening in it, how three-phase power is being generated. That particulars in a simplest manner I am explaining right now, but as soon as I would be explaining in near future or in future contents that it is being loaded and all that, so all the tough concepts starts to be introducing there themselves. So one by one I will be embedding into it, I'll be explaining step by step, but right now I am giving you a very brief, easiest way to understand how three-phase AC power is being generated across the synchronous generator or alternator. So as I said earlier, we have a rotor over which we apply rotatory DC field winding. Why rotatory? Because we are turning it, rotating it. And a DC excitation system is there, which gives it a voltage maybe from 125 volts to 600 volts, and because of this small amount of the voltage, the megavolt ampere power or megavolts are being produced across these ABC three-phase terminals of the armature winding. Here what makes it to turn, what makes the rotor to turn? So we utilize over there the turbines. Turbines are nothing but a flywheel kind of thing, and here we have the blades, means I can draw it again fresh for you. These are the blades given over the rotor of the turbine, and over these blades through jet either water is being thrown or the steam is being injected over these blades. Because of that it starts to rotate, and its shaft is this particular turbine's rotor and our synchronous generator or alternator's rotors are shafted together. So as soon as the water pressure or steam pressure turns it, that rotor turns, and once we have given the DC supply across the rotor winding, it causes the production of north and south pole over here, and same time we are turning it. So what is happening? A DC field is existing over there because of the DC current supplied by this DC excitation. So north and south pole are there, and as soon as we turn the turbine, so this rotor turns, so north and south poles are turning, so this is creating a revolving magnetic field. Maybe number of poles here I am showing only 2 poles, but maybe there would be more number of poles, like 4 pole machine is there, alternator of 4 pole, 6 poles alternators are present over there. So the revolving magnetic field is being produced just by turning a DC field by a turbine, and by turning that turbine is turning the rotor, so we have a rotating magnetic field because of it. Now this rotating magnetic field is causing what? Suppose as per my electrical perception, electrical representation, I have 3-phase winding existing over here. First phase is like this, second phase is like this, third phase is like this. But as I said earlier, this is not the actual physical construction. Physical construction we have, this is the rotatory magnetic field, and outer to it in a cylindrical manner, ring type cylindrical structure, we have the 3-phase winding in the slots of the stators in inner periphery. So suppose over the inner periphery we have 36 slots. So in 36 slots, minimum number of conductors, for how many we can place? 36 number of conductors we can place over there. So individual phase is nothing but having 12 conductors. So 12 conductors of A phase, 12 conductors of B phase, and 12 conductors of the C phase we have. So with respect to this electrical representation, I can explain you that suppose north pole is here, south pole is here, and we are turning it. So here I have A phase, here I have B phase, and the C phase is like that. So these conductors are nothing but subjected to the variation of flux because of rotation of this north and south pole, because of the rotation of the rotor, because of the rotation of the field winding, which is producing the DC flux actually. So continuously these 3 phases, or continuously the conductors which are being placed throughout the periphery of the stator, these conductors are going to be exhibiting the variation of flux with respect to themselves. That means the variation of flux is there with respect to these conductors, because in a physical structure, mechanically, rotor our north and south pole are like this, it is rotating like this, or like this it is rotating. But outer to it, after air gap, we have a stator periphery in which conductors are being placed like this. In a circular periphery, we have the horizontal placement of the conductor. 36 conductors are there. 12 conductors are corresponding to A phase, B phase, and C phase. So these conductors, as soon as this is the conductor, and as soon as north and south poles are turning, so these conductors are being subjected to the, first they are under the impact of north pole, later after the 180 degree it is having the impact of south pole, again it is having the impact of north pole. So with respect to conductor, a regular periodic variation of flux which is cutting these conductors. So individual conductor is going to be cut by these flux, first north pole, then south pole, north pole, south pole, likewise. So with respect to these conductors, if we have the rate of change of flux, so according to Faraday's law, EMF is being induced, and that EMF certainly would be AC type of. Why AC type of? Because a conductor first is under the impact of north pole, later it would be under the impact of south pole. So this conductor, if having the plus polarity of EMF generation due to north pole and negative generation at its back end, so later, as soon as the south pole comes over here, it is coming under the impact of south pole. So this particular terminal would be having negative polarity, and the end one, back end one, is having the positive polarity. So polarity of the EMF is going to be altered again and again because of the rotation of north and south pole with periodicity. So current which is being flowing in this conductor, first in this direction, then in this direction, that way the alteration of the currents are also there. What does this mean? It means the AC power generation is there, AC EMF is being induced, because of which AC current is flowing, and this conductor is of A phase, so 120 degree later, mechanically 120 degree after, this particular conductor is also having the impact of north and south pole, but at 120 degree laggingness. C is also having impact of north and south pole, but having 120 degree phase difference with respect to the B. It would be lagging B phase EMF and B phase current by 120 degree. So that way we have the three-phase AC power generation as well as AC alteration of the currents are there, and three-phase production is there of EMF. So over which the frequency of the alteration, currents direction alteration or the polarity reversal is going to be occurring at what frequency. So certainly that frequency is depending on the number of poles, north and south pole, which are passing these conductors. The number of poles which are passing this conductor would be creating the number of cycles in this conductor, plus minus, plus minus, plus minus. If we have the three pair of poles, means 6 poles are there, so it would be having 3 cycles of the alteration. So that way the frequency of variation of EMF or the alteration of the current's direction is depending on the number of poles existing over the rotor. So right now I am giving you only 2 poles example, and 3 phases are there through 36 conductor. Here 36 conductors is not mattering beta. I am just telling you in what pattern the number of conductors are being associated with a single phase actually. But how the conductors are being placed in the slots of the stator, it is a different discussion and a long discussion. I'll be taking up in 4 to 5 lectures about the armature winding of synchronous generator. That is a different topic. But here, as I am giving you the brief of how the EMF is being produced across the AC EMF 3-phase kind of, that thing I explained right now. And the dipolarity of the EMF in these conductors which are being placed in the slots of stator, polarity is nothing but to be found with the help of Fleming's right hand rule. So the things what I explained right now related to the synchronous generator, to have the perception how synchronous generator works, how EMF is being induced across it, and again it is AC type of how come this north and south pole produced due to DC excitation, DC current, it is producing north and south pole, and how these north and south pole are turning because of the turbine, and it is all together creating the revolving magnetic field, and that revolving magnetic field is cutting individual conductor of the armature winding there. Here I am giving you the electrical representation says that north and south pole are like this. So certainly these north and south pole as they are turning, so the flux linking with these conductors of the 3 phases are changing. Only that particular perception we can get through electrical representation. But here what I explained prior to this with the help of stator, cylindrical structure, rotor structure, all that is the actual scenario which exists. But with the help of these electrical circuits, I can explain you that the north and south pole as they are turning, so the flux linking to these 3 phases, A phase, B phase and C phase, is varying with respect to time. So rate of change of flux are existing with respect to the armature conductors, and the rate of change of flux is there. That's why EMF is being induced. Alteration of north and south pole is occurring, so that EMF is AC type of EMF because it is changing its polarity across a conductor. Whatever polarity exists because of the impact of north pole, just opposite polarity exists due to the south pole. So that way direction of the current, polarity of the EMF is continuously altering, and as the EMF polarity and the direction of current is changing, that means AC EMF is being induced, AC current is flowing, and the frequency of changing or frequency of reversal of the direction of current, reversal of the polarity is totally dependent on the number of poles which are passing those conductors actually. And the direction of EMF is being known through the Fleming's right hand rule. This is all about the briefing of synchronous generator, alternator, how it produces 3-phase power there, that is there. Now the next discussion I would be taking up, that is the why 3-phase armature winding is provided over the stator, stationary stator, not over the rotor. Related to this particular theme, I'll be giving you number of advantages. I will be listing out number of advantages to provide the 3-phase armature winding over the stator in the next video. So hope you have understood all the concepts and the points what I delivered today, along with the usage and the importance of the alternator existing in the world itself. So hoping that you are liking my concept delivery of electrical engineering. So please like my today's video and subscribe my channel and support others also to make understand all the deep electrical concepts, and ask them to subscribe it also. Thank you.